We'll continue our Flutter for Beginners series with the webpage Basic Flutter Layout Concepts. Flutter is different from other frameworks because its UI is built in code, not, for example, in an XML file or similar. Widgets are the basic building blocks for a Flutter user interface. As you progress through the code lab, you will learn that almost everything in Flutter is a widget. A widget is a mutable object that describes a specific part of a UI. You'll also learn that Flutter widgets are composable, meaning that they combine existing widgets to make more sophisticated widgets. At the end of this code lab, you'll get to apply what you've learned by building a Flutter UI that displays a business card. Row and column classes. Row and column classes that contain and layout widgets. Widgets inside a row and column class are called children, and a row and column are referred to as parents. Row lays out its widgets horizontally, while column lays out its widgets vertically. We'll use this example right here. In this code lab, they just have you go through the Dart pad, but we will actually throw it into Android Studio in our case. Doing so, of course, means I'm going to actually implement a Flutter app. Hence, I'm going to define either a material app or a Cupertino app. So let's just run this and see what we get. I'll run it through the debugger. And there we are. Actual size and alignment. So far, the blue box widgets have been squished together, either to the left or to the top of the UI output. You can change how the blue box widgets are spaced out using the axis size and the alignment properties. Either left or to the top. So in other words, from row, it's to the left, or column. Let's do that quickly. I'm going to go in here and simply change that to a column. Let's see. If I do this, comment out that, and I'll change this to a row. Right, then I'll go Control S to save. It'll do a hot reload, and there we are. Okay. Let's continue. Main axis size property. Row and column occupy different main axes. A row's main axis is horizontal. A column's main axis is vertical. The main axis size property determines how much space a row and column can occupy on their main axes. The main axis size property has two possible values. Main axis size max, where the row and column occupy all of the space on their main axes. If the combined width of their children is less than the total space on their main axes, their children are laid out with extra space. Main axis size min, row and column only occupy enough space on their main axes for their children. Their children are laid out without extra space and at the middle of their main axes. The main axis size is the main axis size property's default value. If you don't specify another value, the default value is used, as shown in the previous example. So the main axis. So let's go back. We're going to use this one. We go into its declaration. The main axis by default is max. Okay. I would suspect, of course, changing it to min isn't going to help at all, because it's already that. Main axis colon. Save. Yeah, no change. That's fine. However, if we change the alignment, let's do this. Modify the axis size. The following example explicitly sets main axis size to its default value. Well, that doesn't matter. Either way, again, it wouldn't change. It's going to be the main axis alignment property that makes the changes. When the main size is set to max, row and column might lay out their children with extra space. The main axis alignment property determines how row and column can position their children in that extra space. So the main alignment has 6 possible values. So let's do that. Here we go. That is the default, by the way. So no change. So let's change it. I'm going to change it to center, so it's going to move to the center. There we are. Change it again. Now it should move to the far right. There we are. There's 3 more. Now, if we click on this one, there should be space in between. Right here. There's no space on either end, but there's an even amount of space in between. Right? So now we continue on. Let's try another one. Space evenly. So there'll be space in here and space in here, but there'll be half of those 2 spaces on either end. So there we are. Space evenly on each one. Okay. That's the one I'm thinking of. Space around. There's the half. Perfect. And again, that's all the same with column. Right? Oops. Be the same thing. In this case, the end would be at the bottom. Yeah. Okay. Cross-axis alignment property determines how the row and column can position their children on their cross-axis axes. A row's cross-axis is vertical and a column's cross-axis is horizontal. The cross-axis alignment property has 5 possible values: start, end, center, stretch, baseline. So what we'll do here, we'll modify the cross-axis alignment. Okay. We'll just copy the children inside there. In fact, we'll take the whole row. All right. So we can do this. Boom. I'm going to go comment this out, put this back in. Right. The math bigger isn't defined and type my widget. Okay, down here, 'cause that's just, oh. There's a bigger one in here. Okay, let's grab this. I can see why they're doing that. They're making it a bigger size so that you can appreciate the cross-axis alignment. So let's save that. Hot reload. And sure enough, it's bigger. Space around. Okay. Start. Yeah. And so it goes. Okay. As you've seen, the main axis alignment and the cross-axis alignment properties determine how row and column position widgets along both axes. Row and column first lay out widgets of a fixed size. Fixed size widget considered inflexible because they can't resize themselves after they've been laid out. The flexible widget wraps a widget so that the widget becomes resizable. When the flexible widget wraps a widget, the widget becomes the flexible widget's child and is considered flexible. After inflexible widgets are laid out, the widgets are resized according to their flex and fit properties. Flex compares itself against other flex properties before determining what fraction of the total remaining space each flexible widget receives. Fit determines whether a flexible widget fills out all of its extra space. Okay, the following example demonstrates. Okay, list. Flex fit loose. The widget's preferred size is used default. So that's the widget's preferred size. The tight forces the widget to fill in all of its extra space. In this example, change the fit properties to make the flexible widget fill the extra spaces. Okay. I'm going to copy the whole thing. Bring it in here. Keep the main app. Excellent. Don't need the extra import statements. And we're just going to save that. And saving it, of course, causes a reload. We're right back to square one. Cool. Now, one blue box is left alone. The other two are put in side flexible. Loose means to fill its own size, so that's it. The moment I change that to tight, it's going to stretch that all the way across. Save that, and there we go. Okay. It just fills in force the widget to fill in all its extra space. What extra space? In the example, change the fit, fill in the extra space. In the following example, the row contains one blue widget and two flexible widgets that wrap two blue box widgets. The flexible widgets contain flex properties, and the flex values is set to 1. Oh, right. So if I change that now to 2 or 4, that's going to get longer. Yeah. From this equation here, 4 divided by the total of all flex values. When the flex properties are compared against one another, the ratio between their flex values determines what fraction of the total remaining space each flexible widget receives. In this example, the sum of the flex values 2 determines that both the flexible widgets receive half of the total remaining space. The blue box, or the fixed size widget, remains the same size. Yeah, that makes sense. Right. Again, that is default, so you don't really need to have that in there. Flex default is 1 as well. Let's quickly see here now. Flexible. So flexible. There it is. Wow. A lot to it. Parent data widget. We'll get into that one day. So that's that. Again, that doesn't need to be there either. If I change that to 0, what happens? Nothing. Change that to 1. I see. Okay. Let's continue this. Expanded widget. Similar to flexible, the expanded widget can wrap a widget and force the widget to fill extra space. What's the difference between flexible and expanded? We use the flexible to resize widgets in a row or column. That way you can adjust the child's widget spacing while keeping its size in relation to its parent widget. Expanded changes the constraints of a child widget so it fills any empty space. Okay. Take this and then we'll change it to expanded. Alright, so if I copy this, go back to our source code, replace it like so. Again, we're right back to the same old example. Right. And then they want us to introduce this expanded. Wrap the second one, the second blue box with expanded. So what should happen is this will actually just expand, I think, right across this time. Makes sense to me. Yeah, okay. Let's get on. This is a lot to go through here. The size box. The size box can be used in two ways when creating extra dimensions. When size box wraps a widget, it resizes the widget using the height and width properties. When it doesn't wrap a widget, it uses the height and width properties to create empty space. Okay. So let's just grab that. Yeah, let's just take what's in the children list for this row. Okay, let's just grab the whole contents thereof. Alright. Slap that in there. So this is the main axis. It's going to take the whole space. So it's going to start from left to right. The middle one's just going to be a little longer. So if I change that to 4, it's just going to be a little longer still. Ooh, too long. All right. Let's try that. There we go. Perfect. All right, let's try this then. In this example, they just want you to put in some space. They want to demonstrate the fact that if you don't supply a child, it just gives you space. There'll be times when you just need the space. There we are. There we go. What's this? Similar to the sized box, the spacer widget can also create space between widgets. What's the difference between the sized box and the spacer? Use spacer when you want to create space using a flex property. Use size box when you want to create space using a specific number of logical pixels. Okay. Add another spacer between also the flex value of 1 between the second and third. Okay, I know where we're going here. Again, yeah, we just grab. We're putting space in there again, this time not using the sized box, but the spacer. We'll see how that behaves. Okay, save that, reload. Wow, so it takes up the whole remaining space of that row, the main axis. Quickly take a look at this guy. It's a stateless widget. Flex parameter may not be null or less than 1. It has to be a value. It has to be greater than 0. It's a stateless widget, and in fact it takes advantage of 2 widgets we already looked at. Expanded and sized box. So that supplies the necessary 1, defaults to 1. Okay, so it's used just to take up space, to make space between the 2 widgets in this case, and then they say to put up another one. Alright, I'll do that. And as you know, since flex is default, all I need to do is this. Get rid of that name parameter. It can be just that. And we look at that now, and there we are. Ah, yes, we're coming along here. Okay, text widget. The text widget displays text and can be figured for different fonts, sizes, and colors. All right, let's do this now. Let's grab this. Grab the whole thing. Paste it in there. Don't need the extra. Reload it. Now it's way up there. I noticed the dart pad, it accommodates for that. Again, it puts in the necessary material app or puts in the necessary localization settings that you need. In this case, it puts it in the center. So we're going to have to do it ourselves here. Center. Child. Right? That. Save that. Now it's done. Perfect. Oh, that's interesting too. Alignment. See the base. See if I set that to center. Notice how that changes. The hay is bigger. This one's far bigger. Well, it is bigger than the rest of them. But they have a baseline specified by alphabetic. So it recognizes that these are words, and the baseline, of course, would be where these lines light up. Now, why do we have these lines? I'm not certain about that. So when I go baseline here, they'll all line up along the bottom as they should because they're alphabetical, they're letters. And there we are. If I got rid of this, it wouldn't know what they are. It'll blow up. In fact, yeah, there we go. You get the red screen. Let's put that back. Save that. Hot reload. Centers that. Main axis alignment. Main axis alignment center. Save that. There we are. The icon widget displays a graphical symbol that represents an aspect of the UI. Flutter is preloaded with icon packages from Material and Cupertino applications. Okay, so let's grab this. Slap it in there. See what we get. I'm going to run this one. Okay, cute. Got cute little icons. Change the size. Nice. It's interesting too. Cross center. What if I do column? Yeah. Main alignment center. Save. Okay. There we go. Now, give the icon a color of amber. And add another icon. Okay, I can do that. Add another icon, give it the color of amber. Size 50. Okay. We're in a list. Just going to add another one. Color amber. Save that. Hot reload. There it is. Right? Space evenly. Done. Nice. Image widget. The image widget displays an image. You either can reference images using a URL, or you can include images inside your app package. Since DartPad can't package an image, the following example uses an image from the network. Displaying an image. Okay. Copy the example displays an image stored remotely in GitHub. So there it is. And change it from 3 to 1, 2. Okay, let's grab it. Let's do that. I think I just pasted it. I think I just copied it again. There we go. Do that. Oh, image network. So does that work? Beautiful. Look at that. Then change that short URL to this. Actual URL. Done. Save. Right? Change that to 2. Change that to 1. Save. There we are. Putting it all together. Let's say we do that in another video. And we'll continue putting it all together and create a business card. Until then,